Hi ladies and gentlemen, this is Mr. Green and another in my series of geometry videos, and we're getting so near the end of this unit I wanted to make certain I covered one final topic with you. Area and volume ratios. So far all we've been talking about is sides and looking at triangles. Well, triangles were the easy ones for us to deal with here. And that's what we were looking at was the side ratios, okay? And scale factors. But we've been talking about lots of different types of shapes, really. If you're looking at any polygon, the area of one divided by the area of the other, so A2 divided by A1, gives me a scale factor. Why did they put A2 over A1? It didn't make any difference. I could have said A1 over A2 and it would have still given me a scale factor. It just would have been going from the other way around, okay? But it gives me a scale factor when I'm dividing those areas. That scale factor is actually the same scale factor that we'd be looking at for the side ratios. It's just squared because we're talking about area. Remember on the last test when we worked through that problem where you had the volumes were changing and the surface areas were changing, and we worked through a couple of problems where we showed you that if we had this type of dimension and we increased it by this number, it did things to the surface area and volume. This is where we're getting it from, okay? The area ratios for similar figures, okay? So if they're the similar in shape, they're just increased by a scale factor. Their areas are increased by that same scale factor squared, okay? So let's look at this one. I've got an area here of 24 and an area here of 150. I can actually divide 150 by 24, and that's going to give me my scale factor squared. Well, that's the same thing. If I divide out the sixes, I get 25 over 4. And that takes the square root of that, and I get 5 over 2. So that means the sides are in ratio of 5 to 2. Look at this. This one's 8. What if I was looking to find x here? I could use that ratio. 5 over 2 is going to be equal to x over 8. How do I know to put it x over 8? Well, this is the bigger triangle, bigger number, x over 2. That's how come it went x over 8. Now when I do my means and extremes, I get 40 is equal to 2x. X is equal to 20. We found this length right there, 20. Ta-da. Okay? Do you know what? We could also find the height here. How could I find that height? Well, we know that it's got an area of 150. 150 divided by 20 would give me the part of it here. 150 divided by 20 will give me 7.5. But we know that our area is half of, has that 1/2 in it. So it'd be 7.5 times 2, and it's going to be 15. Our height there would be 15. 15. Okay, 15 times 2 is 300 divided by 2 is 150. Guess what? We would be able to find this one too. It's going to be 4. How am I going to get that? How did I get that? Well, 5 over 2 is equal to 15 over x. I'm trying to find this height over here. And then I would cross multiply or means and extremes. I get 30 is equal to 5x. X is equal to 6. 6 would be this height. Sorry, 6. See, we just found out everything about this triangle just by knowing the ratio the ratio of the sides to each other. 5 to 2, that scale factor. Okay? So if we're looking at two rectangles, can we do the same thing? The scale factor is 3 to 2. Guess what? The area factor is going to be 3 to 2 squared. That's 9 over 4, right? After we square it, 9 over 4. And then when we do the means and extremes and solve it, we would get that the area is 63 meters squared. Centimeters squared. 63 centimeters squared. Ta-da. Okay? Does it work for trapezoids? Why, sure it works for trapezoids. We got 200 over 72. That's going to, or 72 over 200 would give me a scale factor. 72 divided by 200. And that's the same as what the sides are, right? And if we wanted to find the side right here, we could say that's equal to 6 divided by x squared, or 6 divided by cd squared. Same thing. And so when I square that, I get 36 and cd squared. And then when I do my means and extremes and work it out a little bit, I get that CD squared is equal to 100. CD must be 10, because square root of 100 is 10. So we found the height of that trapezoid. Ta-da. Okay? Well, what about similar objects? You know what? If I say that this rectangular prism is similar to this rectangular prism, that means that I should be able to do 1 divided by 3, and that should be equal to 2 divided by 6, and that should be equal to 4 thirds divided by, I'm sorry, 4 divided by 4 over 3. Oh, the other way around. 4 thirds divided by 4. That last one's kind of messy. Mark that one out. Well, you can see that this is 3 and 1, 6 and 2. Right? So 1 divided by 3, 2 divided by 6, 4 thirds divided by 4. And I know, fractions divided by a number, that doesn't work out very easily. Trust me, if you do the fractional work, it does turn out to be 1/3. Cool. Well, how can we use that information? Volumes. The volume ratio is equal to that same scale factor cubed. So we're going to multiply it times 3 because volumes are cubic measures, right? So here I've got 14 and 7. I can see already. This one is 1/2 of this one. 14 divided by 7, that's 1/2. If I cube that, that means 1/2 times 1/2 times 1/2, that's 1 over 2 times 2 times 2, that's 1 over 8. This one is, volume is 1/8 of the other volume. Okay? If we knew this first one was 1120 in volume times 1/8, it's going to tell me 140. I found the volume of the small one and didn't even have to go through a whole lot of the volume formulas. Ta-da. Okay? How about cones? Does it work for cones too? Why, sure. We can see that these altitudes are 12 to 15. Guess what? That's going to give us our ratio, isn't it? I think they're going 15 to 12 is what they're doing this time. Well, 15 over 12 is going to be equal to 5 over 4 because it reduces down. And that's where the 5 over 4 came from over here. That's the ratio, the scale factor, 5 over 4. Cubing that, 5 times 5 times 5 is 125. 4 times 4 times 4 is 64. If I knew the volume of one of the cones, why sure, they're telling us that the volume of this one is 256. We stick that in here. Smaller ones, 256 pi. We work through the means and extremes, and we will find out that the volume of the bigger one is 500 pi centimeters cubed. We did that without even having to go through that ugly formula for volume, 1/3, whatever. Right? Here they're giving me two volumes. We can set those volumes as ratios, right? Volume 2 divided by volume 1, pi's cancel each other out. Zeros cancel each other out. And we got 128 divided by 54. That reduces down to 27 over 64. How do I find the cube root of this? Calculator will do this for us. 27 over 64. Watch this. This is so cool. So I'm going to put a parenthesis in here. 20, oops, back up, clear. It's not liking me right at the moment. 27, clear, parenthesis. Do what I'm wanting, machine. 27 divided by 64, parenthesis. I'm going to raise it. I'm going to find the 1/3 power. Okay? And I press enter. And it comes back and it tells me that. I wanted it as a fraction, Mr. Green. So we push math, we push number 1 to get it as a fraction. And it gives me 3/4. I found my scale factor. It's 3/4. Yay. That means if I know the height of this one, I can find the height of this one. That means if I know the radius on this one, I can find the radius on this one. That's what it means. That's what it's for. Okay? One more cone problem here. They're saying these two cones are similar. The volume of S is this amount, and they're wanting to know the volume of T is this amount. They're wanting to know how the heights are related. Well, you just simply divide the uh, volumes by each other, and you're going to get the scale factor for it. Okay? Well, it turns out to be this is 27 over 8, right? Well, 27 over 8, that's actually 3 over 2. When I bring that down, 3 over 2 is equal to 15 over H1. Well, we can actually multiply by 5, and I see that this one's going to be at 10 as the height on this one. Ta-da. Okay? You see what we're doing? Here we've got a block of ice. It weighs 54 pounds. Weighs? Wait a second. We haven't dealt with weights before. You know what? If I take the volume times the mass, I get the weight. It's just scientific formula I learned a long time ago. So I can actually use this instead of the volume. And it works exactly the same way as volume does. So if I know that one volume is 54 pounds, the other volume we don't know, but we know the height is 1/3 of the other one. 1/3 cubed is 1 over 27. Ratio here means that, okay, means and extremes, 54 is equal to 27. 54 divided by 27 is 2. So a block that is 1/3, this one, will weigh 2 pounds. Easy. Easy squeezy. Okay? I do appreciate the fact that you guys are sending me what course you're in when you're sending me information, and you're sending me what section you're in. It really helps me find your information quicker and respond to you quicker, and that's what it's about, is getting the response back to you. I look forward to seeing you in Class Connect or in tutoring. Talk to you later. Bye.